notes on writing graphs, or writing piecewise functions from a graph, excuse me. We know that we see three pieces here, and we see that our first piece is constant, our second piece is increasing, and then our last piece, of course, is decreasing. We also want to make sure, before we start worrying about things too much in the piecewise function, is let's figure out those arrows. In this scenario, we know that the one on the left is pointing to the left, one on the right is pointing to the right. It's also pointing down, not worried about it because we're focused on the intervals. When we take a look at the first one, that is blue, I see the arrow pointing to the left. So we know that that means that the traveling to the negative infinity, never going to quite get there, so there's no line under that arrow. And then we have the x. It looks as if it's stopping right there at that -2. So in terms of the first interval in blue, that's where we are traveling. The second one, kind of sort of an interesting case here. We know that it starts up at -2. And a little bit of note here. I'm going to go ahead and make sure that if I write the -2 twice in the interval, I want to make sure that one of these arrows has a line underneath and one of them doesn't. We don't want any repeats in terms of the arrows for a specific number. So if I'm writing the -2 during the intervals, one of them gets the line underneath, one of them doesn't. So we'll give it to the green one there, and we'll say that that interval in green stops at the +2 mark. Finally, the one that has the decreasing interval, again, I'm going to repeat a number. There's 2 where this starts. And so I want to make sure, if I'm looking at that arrow and that arrow, that they're not the same arrow in terms of one of them has a line underneath, one of them doesn't. So just make sure you keep that aware. I want to be careful in terms of which function, which interval I would plug into. If those numbers came up, we'd get the same point either way. Finally, we're traveling to positive infinity because of the word right. So those are our intervals for this problem. Let's go ahead now and take a look at the actual equations of the line. The first line is a horizontal line, right there in blue. So no slope. We could actually write 0x. Usually people don't do that. But no slope, all run. All we're worried about is what's the y value there. In that case, it is -4 for that. So in terms of equation of a line, we're just going to write -4 for the constant. The increasing interval with green, we got to check out the slope, and it looks like every single time for our slope we are going up 1 and to the right 1, which would be a positive slope. Does it hit the y-axis? Yes, it does. It hits the y-axis right there, and that y-axis, of course, or excuse me, that y-intercept, of course, is -2. So the green increasing interval is 1x minus 2, positive slope of 1, and it hits the y-intercept at -2. Final thing up is the decreasing part of this scenario. And again, count out the slopes. Down 2, right 1, down 2, right 1, down 2, right 1. So in this situation, we're going down 2, right 1. That ends up being a slope of -2 in this scenario, which we knew, of course, because it was decreasing interval. The problem with this equation is that it doesn't actually, on the picture, hit the y-axis. We don't know what the y-intercept is, but we can count it back out if we follow the pattern. And it would eventually hit at +4 if I were to work backwards and hit the y-axis at the location 0, 4. So that's my piecewise function. 3 different pieces, one that's constant, one that has an increasing interval, and one that has a decreasing interval. By able to take our time with the intervals first, write the equations seconds, and write down the correct piecewise function.